Just as I had mentioned yesterday, the video that I'm going to make of today's class also will be chapter-wise segregated. So there will be different sections for different topics and points that we are discussing. The divisions will be available in the description box of the video. So do please use the videos to have a quick revision of things. And if while solving assignments there are any doubts or questions, of course you can refer to the textbook, you can ask a friend, or you can also look up the video. So we'll start now. We look at echo-related problems and how to solve them. So a typical kind of problem that is asked is if there is a cliff surface and somebody fires a gun, let's say. So there's a bang. Okay. So now, what kind of questions could be asked? The simple thing is you have the equation that is the velocity is equal to distance traveled by time taken. Okay. So typically what they say is if he hears the echo of the shot fired, let's say 2 seconds, or let's make it 3 seconds after he fired a shot, and the velocity of sound is given to you as 330 meters per second. It could be 340, it could be 320, whatever. Okay, so the most of the time I'm seeing that even in the exercises, the velocity is mentioned already. So the question that can be asked is, how far is the person from the cliff? So the distance that is being inquired is this distance. Okay, so this distance is what is being asked for. Now, if you directly apply this equation, right, as somebody mentioned yesterday, what you will get is you substitute 330 for V. You have the distance as it is, and the time is given as 3 seconds, right? So you will get the distance as 990 meters. That is 330 multiplied by 3. Now, the problem over here is that, and often students end up making this mistake, otherwise it's a very straightforward problem to solve, is that what you are doing is you are considering the distance that is taken for the sound to travel to the cliff, the shortest distance we take, right, and then back. That's when he hears it, right? So typically what has happened is the distance that we are talking about is actually 1 time of this. But what you get out of the calculation is twice of this. Okay, so this problem can be solved if you think in terms of first principles. Then you will say that the distance therefore will be equal to half of 990. Okay, and then you can put in your answer. Incidentally, what is the number? What will be the answer to that? When I am teaching,
495.
495.
495. 4?
95.
That right? Okay.
Yep.
So if you solve it this way and you put this as the final answer, no problem, you will get full marks for this. But if you are not sure about this, then there is an equation in the textbook that you can use whenever they are talking about echoes and the distance between the object that produced the echo and the object that that produced the original sound and the object that reflected the sound. So in such a case, they give an equation which automatically substitutes this S as 2 times of D. So then you can write the equation as velocity equals 2D upon T. So when you use this equation, since 2 is already there on this side, the answer that you will directly get will therefore become 330 equals 2 times D divided by 3, right? So you will get 330 times 3 divided by 2 is equal to d. So the answer will directly pop out as 495 meters. Okay, so it's entirely up to you which one you want to use. If you feel I just want to go with the textbook equation, I don't want any muddling up happening, then go ahead, use this equation. Even in the assignments when you're solving problems, use the same equation to solve the problem so that you have sufficient practice of using this equation. If not, you want to tackle it from first principles, then go ahead and do it like this. If it is fun for you to do it like this, go ahead and do it like this. That should also give you the right solution. Okay, but make sure that you understand the question very clearly. What is being asked? Okay, if you are clear about what is being asked, then there should be no problem answering this question. Now, I'll just say one funny question that I came across. It's there in the textbook, and I believe that the year before last in the ICSE paper also they had asked the same question. I'll just read out the question, and you tell me what is unusual about this. Okay, so the question is from 7A, the assignment that I just gave you. In fact, I think I have assigned that question to you. The question is,
what you just said.
beg your pardon? Did somebody say something?
Please repeat what you just said.
From when?
From ICIC board last to last year.
Yeah, so they had asked this question, which is the numerical problem number 8 in your textbook. This is on page 155. Okay, I'm reading out that question, and think it through and tell me what's funny about this question. Okay, it's a bit funny about this. A pendulum has a frequency of 5 vibrations per second. An observer starts the pendulum and fires a gun simultaneously. He hears an echo from the cliff after 8 vibrations of the pendulum. If the velocity of sound in air is 340 meters per second, find the distance between the cliff and the observer. Okay?
Pendulums don't vibrate, they oscillate.
No, you can call an oscillation as a vibration. That's fine. That's not the issue. Yes, you can put a pendulum oscillates five vibrations per second, oscillates 5 times per second. Okay, it's not as if the problem cannot be solved. Numerical problem is perfectly valid. You can solve the problem, but there is some other issue over there. So if you can,
he started the pendulum.
Sorry. Yeah, he started.
What does starting a pendulum mean?
Starting a pendulum means getting it to start swinging. So you have a pendulum. Okay, so there's the pendulum. You keep it ready over there, and then so you hold it to one side like that, and then you do dang, and then you leave. You press the trigger and leave the pendulum at the same time. Okay, 5 vibrations per second, and it does 8 vibrations when he hears the echo. Perfectly valid, absolutely no issue. But what's funny about it? Could you repeat that, Sonia?
Doesn't a pendulum take 1 second to come back to its original place?
Depends on the length of the string.
Yes, you're heading in the right direction, right? So if you have a pendulum which has a length of about, what is it, half a meter, I think, no? Then you have a pendulum that is a second pendulum. So it swings back and forth in 1 second. So over here it says 5 vibrations per second. So what's odd about this? Imagine yourself doing this experiment.
The string will be less than an inch.
Exactly. So it's going to be a very tiny little pendulum to begin with. Okay, because if it's doing 5 vibrations in a second, okay, that means the pendulum goes from this position, passes through the center, goes to the other extreme, and it comes back. It's 1/5 of a second, right? So it goes here and it comes back. It's 1/5 of a second, and it does this 5 times in 1 second. So all I'm saying is this a realistic thing? How can you use a pendulum to measure such a short interval of time? Right? And the problem is, how will you keep track of 8 vibrations of a pendulum that's vibrating that fast? How do you count it? Anybody who has done an experiment using a pendulum will know that is not an easy thing to count a pendulum's vibrations if you have such a short piece of string, right? And the other thing is that the displacement that you are going to give to the pendulum from its mean position, right? If it exceeds anything beyond 15 degrees, yeah, it's going to be a problem. Then it doesn't actually obey the frequency equations correctly. All right. So therefore, if you have such a tiny pendulum, it's going to be a problem actually measuring time. I would say it's just a very silly formulation of a question where it doesn't seem to match with the reality of things. You use a stopwatch. What's the problem with that? But I think they wanted to combine 2 concepts. They wanted to go across the chapters and use the concept of pendulum, which they did in mechanics, and then use that to solve this. Students can solve this problem. It's not like they can't. So if it does 8 vibrations, then you have to figure out, okay, 5 vibrations per second. How much time will it take to do 8 vibrations? And then you can work out the rest of it. It's not an issue. But why I'm saying it is not just to make fun of the kind of questions they ask in the board, but also to kind of be prepared for these kinds of questions, knowing fully well that you can solve the problem, but it may not make entire sense. So that might be an issue for people who follow the first principles kind of thing. You might get confused for a moment. So practice is of essence over there. All right. Anything to say about that?
Arun sir,
Yeah.
then won't the time be 1/3/5 seconds?
Somebody else can confirm that. I'm not sure, but that's just you have to use the unitary method to figure that out.
Yeah.
So if it's like 1 second and oscillations are 5, so 8 seconds, how many oscillations? You work it out. But whatever what you're saying might be right.
But then the seconds will be so weird.
That's okay. You just put it into the equation and you see if it works out well. But that's not being the problem. But it's like weird, yeah. The question is kind of like awkward. Okay, and you expect these kinds of problems. Then there is so this is one kind of an issue. Like I said yesterday, you might also have person standing in between 2 cliffs. Person is closer to one cliff than the other. There is a problem like that given in the exercise also. So he hears 2 distinct echoes, one from this cliff and one from the opposite cliff. So when that happens, how do you figure out the distance between 2 cliffs? Such a kind of problem will have a few more marks and it will probably come in the second part of the paper.